In this lesson, we'll learn about specular ray depth. In this scene, as you can see, I have three spheres with metallic and reflective materials applied to them, and they are positioned in a way that make their reflections visible in each other. Also, I have applied, as I mentioned, this reflective chrome-like material to the spheres. You can check out the material, but it doesn't matter, and you don't need to know how to create reflective materials at the time being. You just need to know that this is a reflective material. As you can see, we have the specular weight set to 1 in the material, and the metalness value is as well is set to 1, so we get this metal-like surface. Now, in the render setting, using specular ray depth, you can define the maximum number of times a ray can be reflected. Let's run the IPR. Now, if I zero out the specular ray depth, you can see immediately we lose all of our secondary specular reflections. Our direct specular reflections that are coming from the light sources are still visible, but our secondary specular reflections are gone as soon as I change the specular ray depth to 0. Now let's increase our specular ray depth to 1. And now our objects have some secondary specular reflection, but still can't see each other correctly, and that is why you see the spheres are reflecting black spheres and do not see each other correctly, because right now we only allow for one bounce of specular rays. Let's increase specular ray depth to 2, and now the spheres look the right way in each other reflections. If you pay very close attention, you might still be able to see some dark spheres in higher levels of reflections. In that case, you can increase specular ray depth again to get the results you are after, but probably for this scene, specular ray depth of 2 would be enough. So basically, by increasing specular ray depths, you can see higher levels of reflections and objects reflecting each other. In this lesson, we covered specular ray depth, and in the next lesson, we discuss transmission and transparency ray depths. See you there.